And here's my third example of setting up a linear program. So we have a problem here. It has to do with one of my favorite things, ice cream. You manage an ice cream factory, makes 2 flavors, vanilla and chocolate. Each quart of vanilla contains 2 eggs and 3 cups of cream, and each quart of chocolate contains 1 egg and 3 cups of cream. Now here's the important thing next. We are limited. See, we have in stock 350 eggs and 600 cups of cream. Then we have some profits on these. And then finally to the problem statement, how many quarts of each flavor should you make to earn the largest profit? And the first step in a linear program is always to figure out what your variables are, and that problem statement helps you figure that out. How many quarts of each flavor? Those will be our variables. Sometimes beginners will think the variables are the eggs and the cream, but no, it's what are you actually doing. You're making quarts of chocolate and vanilla. So for this, our variables, I could use V for vanilla ice cream, and I could use C for chocolate ice cream. I just want to remind myself here that it is quarts. It's not, say half gallons or gallons. Vanilla and chocolate, 2 variables. Next, we have our objective function, which is what we want to maximize or minimize. And here it says earn the largest profit. Largest would be the same as maximizing profit. So we want to go and maximize the profit. So let's create a profit statement using the variables V and C, the vanilla and chocolate variables. Do we earn a profit on vanilla? Yes, $3. And so the coefficient for vanilla for V is 3. Profit on chocolate? Sure, $2. So there we would have the 2, the coefficient on the chocolate, the C. And we would add those together, and that would be our objective function. We want to maximize profit, which equals 3V plus 2C. So we got our variables, we have our profit, and next what we want to do is see if we have any constraints on this problem. Constraints are always either requirements or limitations. Now, what about requirements? Now, the requirements would be like, let's suppose we agreed to sell a local corner store, so many quarts of vanilla. Then we'd have a requirement, but this problem doesn't seem to have anything like that. But we do have limitations, definitely. We only have so many eggs and so many cups of cream. So we will have a constraint for eggs, and then also a constraint for cream. Let's see what it is for eggs. Now, just like up here, the objective function figure, you're going to have a V and you're going to have a C. Now, will we have the V? It depends. Is there an egg figure associated with vanilla? Yep, vanilla contains 2 eggs. So it would be 2 for vanilla, 2 eggs for vanilla. Then you ask yourself, how many eggs go into chocolate? Each quart of chocolate contains 1 egg. Okay, so that would be 1C. Now, an algebra, instructor would say, you don't have to write that 1. It's implied if you don't type it. Absolutely true. But if you use this, and when you later on put this into a spreadsheet, it's just maybe a good reminder to have that 1 there. All right, now what are we limited by in eggs? Well, it says we're limited by 350 eggs, so we have to stay less than or equal to 350 eggs. You might want to hit pause and come up with the one for cream. So cream, does vanilla use cream? Yep, it uses 3 cups of cream. Does chocolate use cream? Yes, that also uses 3 cups of cream. How much cream do we have? We have 600 cups of cream. There we go. Hopefully, if you've watched the previous 2, you're finding this a lot easier. Hopefully, it's becoming easy to understand. Looks to me, scanning it over, like we've accounted for everything. And so what we're ready to do is just the non-negativity requirement would be you can't make negative numbers of quarts of ice cream. So both V and C have to be greater than or equal to 0. There, that went pretty quickly.